Hello, I'm Nathan Oldison. This is the final for this class. Kind of forgot the name of it. But this is for the UR robot. So it starts off the program by releasing, just to ensure that there's no block in there. It goes to start position, where it hovers, like just kind of floating in the open area. Then it goes above pickup, which is resting above where the block will be set. It waits until the sensor senses that there is a block there, disrupting the light that gets reflected. And then it goes to waypoint pickup. That's where it hovers over, where it will inevitably, in the next line, grip the block. And then it moves back up to safety clear, because if you look over here, it would bump into the reflector and bump into the sensor if it goes down and knocks it. So it goes waiting, goes down, grabs it, and then goes back up. And then palletizing set for pattern box. So we've got all 8 of these. And then if we go here, it's set to a 3x3x3. So that's why it places it in a 3x3x3. Approach 1, just kind of resting above where it'll place it. It starts at corner 1, set. We have this empty because there's nothing that needs to be there right now. Waits 1 second. Release node for the gripper, and then waits another second. So it kind of waits, lets go, waits, then goes to exit, which is the same as approach. And then here called after end. After it places all 27 blocks for 15 minutes, it will go finish underscore home, which is at the position it's at right now. So that's where it kind of just rests there to be started again. So, and I don't know if you know this, but we organized it to be a Pokeball, which actually not in a Pokeball formation right now. But, and then last line, halt, so it'll just stop after that. There we are. And then quickly over here, this is for the Omron. Point 1 is where it's at. And then it goes to wait for 1, which is it waits for, wait, which one is this? Oh yeah, it waits for 1. So it waits until it's here. The conveyor will wait until this is here. And then it goes to release, it'll let go. And then if there's no grip, it goes to part 3, which then goes down, so it opens. And then here is where it grips. So let's start with no grip on this side. So no grip, it goes back to position 1. So if it goes down to grab a block, let's see if it'll do it now. No, it won't, so it stopped. But so it goes down to position 1. If it doesn't grab a block, it'll go back up. And then it'll pause until you press unpause here. And then, but if there is a block, it'll go to point 4, which is like right over here, clearing the spot. And then it'll go to point 5, right over here, like resting above it. Point 6, which then gently lowers it down, because this precision matters for the pallet. So it'll go right where it gently places the block onto the conveyor, and then release goes to part 7, sets 1, so that will set the conveyor to go once it moves out of the way. And then this block goes back to part 1 to restart the thingy, my bobber, the code. Okay, now to the sensors. This is the digital input, so it's either a yes or a no. So if there's light reflected from here, then that'll get a signal. So if I block the light turns off, it's triggered. So this goes all the way to the PLC, where it is plugged into negative ground there, 24 volts there, and then neutral over here. And then also, you follow this wire, which then goes from the PLC all the way over here, the red one, this goes into here. So this is sending a signal to the UR robot, the universal robot, of an output. So this gets power, the sensor gets power through the PLC, but it also sends a digital output to the UR, so it knows that there's something here. And then this little block, we were running into some problems where it wouldn't stop in time, and it would kind of be inconsistent. So this just adds that level of consistency that we need, so we don't break the machine. Trying to run through this real quickly. Over here is the sensor. These ones are not digital input. It's not a yes or no. It's a large, what's that word I'm thinking of? Spectrum, I think. Spectrum of different inputs it can have. So that gets over here at the PLC. It gets converted over here. So the 12,000 refers to both sensors. So this is like a yes. This is turns it into a digital by being a yes or no. Is it closer? Is it farther away than that far? Or is it closer than that far? So this just basically simply turns the analog input into a digital input. So, yep. And these plug into the PLC, both here. These resistors are 550 ohms to bring it down to, brings it down to the voltage that it needs, because it works a little differently than others. And then also through this orange wire sends to the Omron robot. Sorry, I've been here for a little while. Okay, and then pneumatics for that. This doesn't have any. Okay, now. And then over here for the arms working themselves, it was a 15-minute video to do the whole cycle. So I'm gonna have to just speed it up time in the future. But as you can see, the Omron has a block in its hand, places it down, lets go, and the UR right now is frozen because the sensor hasn't been tripped yet. So as you can see, then it goes, sensor tripped, goes up, and the UR, well, I forgot to place one there, but as you can see, it stopped. You just unpause it to keep it going. So it even has a fail-safe there. So put a block there. The UR placed the block where it needs to, and then over here, the Omron is placing it on the conveyor. UR is waiting for the Omron to have the sensor tripped. And another thing that we ran into is, you'll see it in the future, but once the Omron places the block, the conveyor actually waits for it to move up. So the Omron has a, what's it called? An output that goes to the PLC. So goes down. Let's go. Conveyor hasn't started yet. Then once it moves out of the way, then it starts. So that was a problem we ran into, but we got it working. So I'm gonna speed up time so you don't have to spend 20 minutes here.